What is up, Joe Gamers? This is our another Calc 3 video. Yay. So, today we'll be talking about maximum and minimum. And, since we're talking about calculating, you should know that the max of a function or a min can be found through getting the derivative of a function and setting it equal to 0. So, for multivariable, what needs to happen is both f of x equals 0 and fy equals 0. But as you know from normal calculus that a crib point, which is just a point where the derivative is 0, or when the slope of the actual graph is a straight line like this, we know that it can either be a minimum, maximum minimum, and neither. So the same concepts apply in multivariable, where just because these two are 0 does not mean they're maximums or minimums. They can also be what is called a saddle point, which, as the name implies, is where it's kind of like, it's like a Pringle, the shape of a Pringle, where, like, I don't know how to draw a Pringle, but it's kind of weird to draw a Pringle. See if there's a Pringle shape here. Probably isn't. Pringle. Wow. Pringle.
ABC Thursdays after an explosive season finale.
Okay.
Grey's Anatomy is back.
Well, I'll just go find that graph. Alright, so here is what I mean by a saddle point, which is at the 0. As you can see, it is a Pringle, and if I make it shorter, even like a little bit more shorter, actual Pringle size, maybe I'll plus 1, no wait, plus 1, oh my days, where'd it go? Oh, probably shouldn't have. So, you see the Pringle, from this direction, it goes to max, but from this position, it's a minimum. So it's kind of neither. And this is what the graph looks like without the restriction. Looks kind of like this. So yeah, it doesn't always have to look like this, but this is just an example. Alright, so we're back. So yeah, that is basically the idea. And what's the as you know, there's the second derivative test in one variable calculus. Now there's actually fast double derivative test in calculus 3. Let's say the derivative of AB is equal if this D, this is gonna equal the double integral of f at the point AB, which is probably the crib point, times the double integral of respect to y at the same point minus the double derivative of both x and y at the same point squared. And that's it. I think that's the equation. Yeah, so D sub AB. So D, I don't know what this, I think it represents something. Double derivative or whatever, I don't know. Hold on, let me search it up. Alright, so D is just called the determinant or double derivative test. There's no actual, I don't know. Anyway, so, here's the condition. If D is greater than 0, and f of x is um less than 0, then at that point f of ab is a minimum. Just like how a minimum would have a double derivative greater than 0. So then
Wish you could become a
that
morning
means
person? You know, the type up
it's
before the
pointing
sun,
up,
early
and
morning runs, first one to
this
the office
derivative
with donuts and a smile. How do they do it?
is this
Easy.
double
With the
derivative
new
is greater than
Galaxy
0
Watch
because
8.
it's
Sleep
up, just
tracking and
like how the
personalized
minimum
insights from
looks
Samsung
is
Health
a
help you
concave
improve so
up.
you can wake up to a whole new
So that's how
you.
you know it's a
One who,
minimum.
dare I say it,
And the
stays the
maximum
snooze?
would then
It's
be when
possible.
this is
Train
greater
your
than
sleep with
0,
Galaxy Watch 8. Learn more at
and this being
Samsung.com.
greater than
Requires
0
compatible
just
Samsung
means there's a
Galaxy phone,
point
Samsung Health app, and
at
Samsung account.
which, yeah,
At
where
Postmates, we don't just
fx
get food to people in LA. We give
is
LA. When
less
you
than
land in the car
0,
at the
then
same time as a
fab
cold, we
is a
get you bone
local
broth and ginger
max,
shots. When your therapist vacation overlaps
because
with your
a
breakup,
maximum
we get you a juicy bacon
is
cheeseburger.
concave
When your landlord
down,
is also an
so
influencer
it was
and
trying to
DJ,
apply,
we
because
get you
if we
a
get a
triple
3D
espresso
graph,
with a sausage,
let's
egg,
draw
and
this again.
cheese. Delivering the food you
Get a
love
3D
in the city
graph
you
and
love
you
when you
split
need
it
it
up with
most.
just
Postmates, we
fx
get LA.
or
Product
fy. You
availability
split it
varies
and
by
you see
region.
the
See app
curve
for details.
that you
I'm the
applied
health
the
ad.
second
Thanks to
derivative,
Caldi, partner with
and you get
Better
the
Health to share
same
health
result of the
therapy
maximum
help
minimum.
Tim. I have neglected
Anyways,
to look after my
so
children
when
past,
d
both mentally and physically, and
is less
I
than
have
0, then
made
it's a
promises to myself
saddle
that I haven't
point,
kept. I think for me, it's accepting that I'm always going to have this stuff there.
and
It's about
d
how I
equals
respond.
0
The steps I
is
take remain
no
at like
info
base
given.
level. Learn more about online
Yeah.
therapy and save 10% at betterhelp.com/Spotify Music.
So another way to write this equation is through this determinant form, which is d equals determinant f of xx f of xy. Also, by the way, this is, wait, I don't know, actually, I'll explain why that's squared in a moment. So this is 3 different ways to get, oh, wait, did I write this right? No. This is 4 different ways to get the double derivative of any function. First is getting the double derivative of the same, these two are the same variables, you get double derivative of the same variables twice, and then the other ones are switch order. And f of xy, and I think I said this before, but the double derivative of interchanging variables are always the same. The proof, I don't know, I pulled it out of my butt, but yeah, just know that's a rule, or yeah. So when you take the determinant, you multiply these two and these two, and you do it this first, then this, and you minus when you do it the second time. So this would be fxx. Well, I mean, it's in this form. Yeah, not writing that again. And since these two are the same, I can write fxy squared or fyx squared. It doesn't matter. It'll give you the same answer anyways. So, let's see what time I got. Now, I'm not gonna do this problem, like, just doing that only, because that's rather simple. What's actually, difficult is domains, and this is a different D, this is a domain D, not an equation. And, say a domain, say there's a domain, a closed set in the 2D world, we can write that, it could be a disk or a square or whatever, but yeah, a disk. So if your domain of x, y, and let's say it's a circle, and it's enclosed with a space of 1, so we would have this. Say this is a 3D function, it's your simple domain of GJK. It's asking for, like, it's kind of like endpoints in one one variable calculus, where if I got this point and this point of the function, you can test for max and mins, but you also have to test the endpoints. Now, when your endpoints are no longer stuck to one point and stuck to a 2D graph, there's a different way to do this, and why is the music so trash? Hold on. Alright, so what do you do with domains that are square-like, rectangular, circular, I don't know, something, equation that is closed? And, usually you're gonna deal with just, closed sets like these squares, rectangles, and circles. And they're bounded by, in the second dimension, 2D dimension. But what's important, right now we're not gonna use circles as our sets. Also, the set is not closed. If there's like some discontinuity or some hole or whatever, just even the tiniest hole, it makes it discontinuous, so it has to be like fully open, I mean closed. So what's actually important about this, especially with the square domains, is we're gonna be working with square domains because circle domains is harder to do because there's so many points on a circle. But with a square, you can linearly find your answer, your maximum, your endpoints. So we're gonna be doing a practice problem with that. Let's see this. Yeah. Okay. So next video, I'll probably teach you how to get the max and min endpoints of a circular or whatever, or any function actually, any restrictions to the domain. But for now, we're gonna use only square domains that are typically. Let me see what type of. Let me get an example real quick. I'm in the wrong section. Hold on. Alright, so let's see some examples real quick. Alright. Brian, what the hell are you songs? There you go, that's done. Find the absolute max in the function on rectangle D. This is D, and it's equal to oopsies, that's not supposed to be there. Alright, so on a graph, this would start from 0 to 3, and this be 0 to 2. Just don't mind the graph, actually, it's pretty bad. But yeah, that's the domain. I'm not gonna graph this function because we're not. But that's how you start. So first, let's get d of AB. Right? Let's get some values of AB. So f of x and f of y equals 0. And these are equal to 2x minus 2y. And this is equal to negative 2x plus 2. And then this would just equal to x equals 1, right?
Achieved clinical remission, and some patients also achieved endoscopic remission. Individual results may vary.
Yeah.
Is a prescription
And then
medicine used to treat adults with
if you
moderately
solve
to
this,
severely
you get
active ulcerative
x
colitis.
equals y.
Serious allergic
So
reactions and
y
increased
also
risk of
equals
infections may
1
occur.
because of
Before treatment,
this.
your doctor should check you for infections
Any
and TB.
point
Tell your
we need to
doctor
have
if you
both
have an infection,
points
flu, or
0,
symptoms, or if
so
you need a
we can just
vaccine.
plug
Ask
directly
your
in
doctor if
here to
compliance can
find where
help you
both of them
manage
are
the cycle
0,
of UC symptoms.
because it
Call
says that x is equal to y
1-800-566-7736 to learn
wherever,
more, or visit
whenever this is 0.
travelhealthradio.com.
But
At Ralph's, you
we need
never
to find the
compromise.
point
You get high
where they're
quality
both
and low
0.
prices.
So
Like you
when
never
x equals
compromise
1
your
is
meal
0
with
for
our
here,
spring
and it
salad
says
kit
x
that's
equals y for
guaranteed
any
fresh.
point,
And
and
you never
x equals 0
compromise your
at 1,
budget with low
then
prices
y
in
will
every
also be
aisle.
equal
Ralph's
to
shoppers
1
never
and become
compromise.
0.
Ralph's,
So
serving SoCal for over 150
we have the
years.
points
Save
1,
big on your
1.
favorites with the Buy 5 or More Save $1 each sale. Simply buy 5 or more participating items and save $1
And
each with your card.
that's all.
Ralph's, fresh for everyone.
So
After visiting Plaza de la Familia at Disney California Adventure Park, you'll remember the music, the food.
okay,
but
so we're
most
not
of
gonna
all,
use
the time spent together as a family.
we're not gonna
August
use the
22nd
wait,
through
are we?
November 2nd. Visit Disneyland.com for details.
Sure, why not? Why don't we just use D real quick to see if it's a max or min? So f of x, x1. Actually, no, we're not doing that. We're just plugging in directly to f. F of 1, 1 equals 1 minus 2 plus 2. That's just 1. And now for the endpoints. So that 1, 1, which would probably be like right here. So this is where our crit point is at. Now we gotta find other points, the endpoints. So what we're gonna do first is check the endpoint 0, x equals 0 or y equals 0, and we'll either go this way or this way. So whichever. So let's try going this way first. So we got x of 0, and that would equal x squared. That's it. From 0, x then greater than 3. And we see if we took the derivative of this 2x and make it equal to 0, then its crit point would be at 0. So f of 0, 0 equals 0. So that's probably aside for min, but we'll just keep it here real quick. Alright, next. The hell is happening to the music? So we made it from 0 to here. I also had to try f of 3, because this is 3, 0. Since this is also an endpoint, I also gotta test it, I think. Yeah, we do. We have to test the range, we have to test these values, and crit points. So if we try f3, 0 of x squared, we get 9. Okay. Next, let's try going up. So f of 0y would just equal 2y. Alright, so we try 0. Well, actually, yeah, we'll try 0. Let me see where I put this real quick, actually. Yeah, so we're gonna try. The only crit points we can have is 0 and 2, so we can only try f of 0, 0, 0. F of 0, 2 is 4. So we got f of 0, 2 is 4. Alright, now we gotta do this side. So f of 3y, that's equal to 9 minus 6y plus 2y. And let's see. Okay, so that's equal to, let's see, 9 minus, let's see this real quick. Yeah, 9, wait, yeah, 9 minus 4y. And this is between 0 greater equal y greater equal to 2. And we take the crib point, we get negative 2y equals 0, and that's still the crib point at 0. So f of 3, 0, we've actually done that, and that's already 9. Let's just check again. Wait, yeah, let's check. 9 minus, yeah, it's don't need to check. And then 3, 2, we get 9 minus 8, that's 1. So we can put that there, 3, 2. Alright, last line is from here to here, which is f of, this line is f, what is this line again? What are you doing at first? Oh wait, yeah, x2. So we're gonna start at top here at a constant 2, which is equal to x squared minus 4x plus 4, and that's just x minus 2, I'm pretty sure, yeah, squared. If I am correct, yeah, it is. And we don't really need to do anything. We already know that the minimum this function can be is at x equals 2, and the maximum would be 0. But let's just check just in case. Alright. So if we took the derivative of this, it would be 2x minus 4. So x equals 2 is a crib point, right? Yeah, x equals 2 would be a crib point, so we have to test f of 0, 2, f of 2, 2, and then f of 3, 2, which we already know from here, so we don't need to check that. And f of 0, 2 is already this, so we don't have to check that. So the only thing we do have to check is 2, 2, which is, we already know as 0, so yeah. So this is also 2, 2. And based on these values that we just got, we finished the endpoints of all of the zeros here. I mean, all the endpoints. So checking all this, we know that now.
Things today can seem kind of unpredictable. Who knows what's around the corner, right?
Boundary
Well,
man.
Total Wireless, we want to give you something to be sure about.
Alright, so
With us, you save 50% off
why the
metro
hell
and
would I
cricket
write that?
when you switch with one line, guaranteed, and you get to keep the phone and number you love. Visit
Alright.
our Total Wireless store today.
Yeah, okay, so
50% savings
this
off
should mean that
comparable Total Wireless unlimited phone plans and plan rates. Some customers may only receive guaranteed savings after contacting us and validating the current plan rates.
this boundary.
Bring your phone rates. For total 5G unlimited plan or higher, auto pay required. Applied on
Alright, okay, I see.
terms apply.
So now
Sweet tarts
we
dared
finished
to
all the
combine
things.
unexpected
Oops, I
flavors,
did that.
and when they did, something
So that
unbelievable
means
was created.
the minimum
Sweet
is
tarts ropes.
0,
The perfect
0,
combination of
and
sweet
2,
and
2
tart flavors in a soft and chewy rope. Sweet tarts ropes aren't just the candy you grab
are
when you want a
absolute
little treat.
mins.
They're the candy you deserve. So go on, spark your senses
And
in every bite.
f of
Sweet tarts
0,
ropes,
I
dare
mean
to
3,
combine.
0
Tap the banner or visit
is
sweettartscandy.com to
absolute
shop now.
max. That is all.